Okay, so here we're going to talk about reference angles, and as I stated before, this is kind of like being able to add, subtract, multiply. So when it comes to trigonometry, this is one of your fundamental skills that you need to make sure that you're comfortable with. So we'll go through each one and just kind of go through and talk about a few things here. We're going to start off by looking at the angles of our quadrants. And each quadrant, so as I rotate from here to here, that's 90-degree rotation. So each quadrant is a total of 90 degrees. So 90 times 4, there's 4 quadrants, is 360. 360 degrees in a revolution. So, and this would be 270 degrees and back to 0, and we'll also call this a 360 mark. So now, that allows me to approximate where these angles are going to be. And I know, so for the first one, this 212, I'm going to go ahead and graph this, just a general picture here. And so we always start on the positive x-axis. I'm going to rotate counterclockwise, and this would be approximately 212 degrees. And so the reference angle is the distance from, or the rotation, I should say, not distance. It's the rotation from the terminal ray, which is this guy right here, okay? So this guy right here is our terminal ray, and we are going to rotate to the nearest x-axis. So the closest x-axis is going to be this guy right here. So this right here is my reference angle. So what's that value? Well, one of the reasons you guys talk about geometric properties before you talk about trig is the fact that we have a basic angle rotation, and we can use just a matter of addition or subtraction to find our reference angles. Your book is going to have something different. I'm not a big fan of it. I'm maybe more of a visual person with this, but as I rotate through, I've gone 180 degrees. The excess, which creates the 212, is also my reference angle. So for this guy, when I'm in the third quadrant, I'm always going to take my angle and I'm going to subtract 180 degrees from it. And so when I do that, I get 32 degrees. So that's my reference angle for number 1. Okay? So, I'll put a little graphic up with how we can identify the reference angles per quadrant. Okay, so let's go to the second one. So I'm going to go ahead and clear the graph, and then we'll go ahead and continue with the second one, and we'll kind of cruise through the rest of them a little bit quicker than this one. Okay, so the software didn't allow me to erase this guy, so we're done with that one. That's our previous example. So now we're going to do 2. So a negative rotation, which means I'm going to move clockwise instead of counterclockwise. So here's where my angle always starts, and then I'm going to rotate negative 340 degrees. And so this is approximately negative 340 degrees. Now, we could do, we know that a full revolution is 360 degrees. So hopefully we can just say to ourselves, hey, our reference angle right here is equal to 20 degrees. That's our answer. I think that is just, when we're in the first quadrant, it's pretty straightforward. There's not much thought process other than the fact that, hey, I've gone backwards. The reference angle is a complete revolution. How many more degrees to a complete revolution? There's 360. So really, if I take 360 minus the 340 degrees, and that's with a negative angle. Okay, so with a negative angle. And we'll see that our next example, number 3, okay, so we got this one. What happens when we're in the first quadrant? So I'm going to go ahead and graph this real quick. We have our angle rotation, and this is a 40-degree rotation. And so here's our angle rotation, and our reference angle is from the terminal ray to the positive x-axis. So when we're in the first quadrant, right, this is our first quadrant, our reference angle is whatever our angle is. So the answer to this is 40 degrees. Last but not least, I'll do that up here because the other one is locked. So here's number 4. We got number 3 taken care of, 124 degrees. So we're in the second quadrant. So let me go ahead and draw my angle rotation. 124 degrees. It's approximately there. And keep in mind that I know approximately where these guys are because I know the 0, the 90, the 180, and 270. So this is just an approximation. And so this is 124 degrees. So with this guy, I know that right here is 180. Hopefully we're getting to the point where we know that this guy right here is our reference angle, right? That's from the terminal ray to the to the nearest x-axis. So I've gone 124, and this little piece right here is going to connect me to the 180. So if I take this away from 180, it leaves me with my reference angles. So 180 minus the 124, and we can put our degree symbols there. If you don't, it's not a big deal. And that's going to give me 56 degrees. And that's how we're finding all those reference angles. Okay, so real quick. And try and get this to be a decent size here. Okay. And I'm just going to draw a coordinate graph here. And there's a couple things that I want you to write down. So this is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Okay, so now, reference angles. Let me erase that. That happens. There's a little wrist guard here that I can slide up and down, and sometimes I miss it, and so I draw a line on that side. Sorry about that. So this is kind of a tool for reference angles. Okay? If I'm in the first quadrant, my reference angle is equal to my given angle. Okay? So any angle between 0 and 90 degrees is going to be whatever the given angle is. If I'm in the second quadrant, my reference angle is equal to 180 minus the given angle. Okay? If I'm in the third quadrant, my reference angle is equal to the given angle minus 180 degrees. Okay? And then last but not least, if I'm in the fourth quadrant, my reference angle is equal to 360 minus my given angle. Okay? I think the first and the fourth are visually easier than the rest. Okay? The second and the third quadrants, you just need to keep it straight. This one we're subtracting our angle from 180. This one we're subtracting 180 from our angle. So it's just flip-flopped. Notice the degree measurements that I'm always using are 180 and 360. I never use 270 degrees. Never, never, never. Okay? Just want to emphasize that. And so this is how we're going to find reference angles. And once again, this is an important fundamental skill in trig going forward through the rest of your classes.